Okay, so today we're going to be talking about geometric probability. And probability in general is when you say how likely is something to happen. And sometimes that's with weather. Sometimes that's just in, like how likely is it that your mom's going to say yes? But we can talk about the math of it saying the probability is the number of options that you want over the total possibilities. That's one way to describe it. And so, if you're trying to win a game and there are 5 ways to win out of the, 10 options, well, there's a 50% chance that you'll get what you want. Okay. And so flipping a coin is 1/2. If you're spinning a spinner, you can look at, which ones will help you win and which ones won't. And so it's what you want out of the total. Also, you can do it based on experience to say, hey, how many times did what I want happen out of the total number of times that the event occurred? And so those are 2 different ways to write that fraction. There's a lot more to probability, but those are some of the basic things that we can talk about. Another thing would be the scale. Okay, if it's 50%, that means it's equally likely to occur or not occur. Okay, 1/2. If it's anything above that, it's more likely than not. Okay, anything below that is less likely than not. And then 0% is impossible. Okay, 100% or 1 would be the most it could be. Okay, you can't have a probability higher than 1 or 100%. Okay, that's just not going to happen. And so we are going to talk about this in terms of a simplified fraction, or you can write it, if you divide your fraction, numerator divided by denominator, you can get a decimal, or you can divide your fraction and then make it into a percent by timesing by 100. Okay, and so theoretical is in theory. Okay, and so it's like if you flip a coin, it's 50% shot that you're going to get heads or tails. But actually, if you try it, I believe that one side of the coin is actually more likely to happen. If you Google it or try it, you may notice that half the time you don't exactly get heads versus tails. And so your experience actually helps you talk about your data set. Okay, and so and you can actually do an experiment and say, well, in my experience, 40% of the time I get tails, or 45%. So, and that would be experimental versus hypothetical. Okay. And so there would be theoretical versus experimental. And so you may work with that at a later date as well. Geometric probability is what we're going to say is the ratio of some measurements geometrically versus of what you want versus what the total options there are. And so we can do that with points on a segment. We could do that with places on an area. You can do this with a statistic. So if you take stats ever, okay, you will be talking about probability. You'll be talking about, does data make sense? Is this a valid conclusion to, based on our data? But right now we're just going to keep it pretty simple as talking about geometry with the probability that something will happen. Okay, and so if you are looking at a segment, there are infinitely many points on every single segment. And so the question is, what's the probability that if you're going to just pick a point from that segment, that your point is going to be within 2 locations, a location of A and C, those 2 points. And so the thing that we're going to do is we're going to say, okay, well, how big is the segment from A to C? Well, that segment is going to be 7. And how big is the entire segment we're looking at? Well, that is going to be 12. And you could leave it as a fraction. You could reduce the fraction if it does. You should reduce it actually if it will. You could divide it by doing 7 divided by 12. If you want to make it into a percent, not only divide 7 divided by 12, but then you times it by 100, and that will give you the percentage that you're talking about. So we could divide it and times it by 100, or we could just leave it as a reduced fraction. So those are 3 options for this problem here. And so it kind of depends on what I ask you for. I'm grabbing my calculator real quick. So, because I don't know 7 divided by 12 out of my top of my head, we could write 0.58, okay? And so we could compare that, 0.5833, and then 58% if you times it by 100. Okay, and so that's more likely than not. It's not certain, but it's more likely than not going to happen. And so you can look at that chart at the top to kind of see how could you use words to talk about the situation, okay? Okay, now moving here, it says, what about if it's not on the segment from A to B? Well, if we don't want it here, well, then we do want it over here. And so we would say that would be 8 out of 12. And that reduces to B divided by 4, you get 2, divided by 4, you get 3. So 2/3 or 0.667%, 0.666, or 67% approximately. Okay, so we could do whatever method that is, fitting to our situation. Okay, the last one. What is the probability that the point is on A, B, or C, D? So this is A to B, and this is C to D. We want it on either one of those. Either one is fine. Well, we've got 7. Actually, 4 plus 5 is 9. So this is 9 out of the 12. Divide it by 3, and you get 3/4, and that's 75% likely that it lands on one of those two locations. And so we're choosing a point because there's infinitely many points. We're focusing on the length of that and saying, okay, what is the probability that it is from that location? Okay, moving forward, we're going to actually move up a dimension. We're going to talk about area. And so in area, we want to say, well, what's the probability, like dartboards, to be like, okay, what's the probability that we land on this specific ring if we're playing darts or if we're trying to, who knows what with your shape. And so, but we're going to assume that you're going to actually hit the dartboard. Okay. And so it's not like you're going to miss, because then the probability changes. And then also that each point has an equal likelihood of occurring. Okay. And that's not necessarily fair, but we're going to go with that. Okay. And so if this radius, the radii of this concentric circle is going to have a radius of the skinniest one would be 1, the next one would be 3, and the following one would be 5. What would be the probability that it lands in the shaded region? And so in class, I just let people go and say, okay, try it. And so the area of the biggest circle, okay, assuming that that's our location that we're going to make sure we land on, would be 5 squared times pi. Okay, that's the overall area. And then the area of the shaded region, well, we got to subtract. Okay, so we're going to find the area of this mid-sized circle and subtract out the inner circle here, because we want just the area of the blue ring. Okay, and so if we find the area of the middle-sized circle, we are going to do 3 squared pi. And we're going to subtract from it the little circle, which would be 1 squared pi. Okay, and so that would be 9 pi minus 1 pi. Okay, that's 8 pi. Over the denominator is going to be 25 pi. And we can reduce out those pi's. So the ratio is 8 over 25. We could divide it or make it into a decimal or percent if we want to. Okay, and so if we do that, let me see what likely it's 8 divided by 25. That's 32%. Okay, and so I divided it and times it by 100 to get the percent. So geometric probability, we just find what we want out of the total. Okay, and so the next one is, okay, say that our circle that it's going to land on is this green circle, and we're wondering what's the probability it lands in the green part as compared to the white part. And so we want to find out what that probability would be, assuming that this radius is going to be twice as big as the smaller one. Okay, and so we've got to find the area of the big one. Okay, so to find the area of the big one, we're going to do the radius squared. And the thing is, the mistake that kids make is that they forget that it's 2r is the actual radius. It's not 2 times the radius squared. It's 2r is the radius. And then that will make the area of the bottom, or the biggest circle, to be 4r squared pi. And then the top is going to be, we've got to take the big circle's radius and minus out the small circle's area, And so let's do 4r squared minus, and then the small one would be r squared, and that would be 3r squared. And then pi, 3r squared pi. And so if we reduce that, the pi's will reduce, the r squares will cancel out, and you're left with 3/4 or 75%. Okay, and so it's kind of weird because if you look at that, you're like, maybe it's like half. Well, no, there's a lot more green area than there is actually white. It's because it wraps completely around it. And so therefore, it is bigger than perhaps what it looks like. But if you kind of plotted it out, you'd be like, oh, yeah, I guess it is 3/4 of it is green. Okay, the next one would be, as shown, what's the probability that the pointer lands on yellow? Okay. And we can find the area of these locations and write that fraction. But we could also say, guess what? Proportionally to the circle, the fraction of the circle that is yellow is 45 degrees of the circle. Well, that's not 45%, so don't put that, but it's 45 degrees out of the 360 degrees that we have. Okay, so that's kind of interesting. Like, you have to say, well, what is the total? And then we can reduce that, and we get 1/8, and we could divide it and get a decimal, and then times by 100 if we want the percent. What's the probability that it lands on purple? Okay, you're like, I don't see any purple, but it does name this one to be purple up here. So I guess this is purple right here. And so we're going to say, well, that's 105 out of the 360. And we could reduce that as well. And we get 7 out of 24. Okay, we could divide it if we want to as well. And then what's the probability that doesn't land on red or blue? So you're like, red or blue will make me lose. So we don't want to get these two. We could land it on any of the other colors and still be fine. And so the probability that it lands on any of the other colors would be, let me look and see, 240 out of 360. And then if we reduce that, we get 2/3. Okay, and so that'd be 67% approximately. So on your homework, there is a diagram that doesn't have colors labeled. And so I want to let you know, I guess we will call this one red down here. This one is going to be blue. This one, I guess, is purple. Okay. It's more like, I don't know, Cabernet or something. I don't know. This is yellow. And this would be green. And I'm saying that because I know you guys know your colors, although there are people who are colorblind. So they actually need the words to help them know which one is which. All right. Thank you so much. Have a good day.